Welcome to the notes for 6.6. This is division of radicals and rationalization, which will make more sense in just a moment. So first, remember that a simplified form of a radical, which is what we're going to really spend our time on in here, is written as a product of prime factors. If it is simplified, the following conditions are met. The radicand, what's underneath the radical, has no factor raised to a power equal or greater to the index. So like the cube root of radical x squared is simplified, but the square root of x cubed is not, because there's a perfect square to take out of there. That's a 2. The radicand does not contain a fraction. There is no simplified thing that looks like this. That's not cool. And there's no radicals in the denominator. So if we take this apart into this, it's also still not cool. So what we need is a strategy for dealing with that, and we're going to get that today. One thing to remember is that I can, if I have a fraction underneath a radical, so the cube root of 8 over 27, break this up into the cube root of 8 and the cube root of 27. Sometimes it makes sense to divide this fraction first and simplify it. Sometimes it makes sense to break it up. We just have to do what makes sense in each step. All right, so we're going to simplify here. Now, there is no like way to simplify a to the 6th and b to the 4th just by themselves. They're under a square root, so I'm going to take the square root of each one. I'm going to break up that radical. That is going to become the square root of a to the 6th is basically 6 divided by 2 is a to the 3rd. The square root of b to the 4th is basically 4 divided by 2, b squared. That's what it is. That's our answer there. Okay. The next one, the cube root of 81 square roots of 5, or 5th root of y, sorry, over the cube root of x cubed. So we're going to just break this into pieces. First, we're going to break the radical up. So I'm going to put 81 y to the 5th on top and the cube root of x cubed on the bottom. Then we're going to keep moving. So then I'm going to break up my roots just like I've been doing all along in the past bunch of sections. Cube root of 81, cube root of y to the 5th. Cube root of x cubed is just x, so I don't have to stress about that one. That one's just done. Cube root of 81 is 4, right? I think. Oh boy, let's make sure that works. My brain is not working. 4 times 4 times 4. It's not. That's totally wrong. Ay, 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 what happened? Cube root, oh, I know what I did wrong. I needed to break it up more. Holy moly. Sorry, this happens to all of us. Is I can break up that into the cube root of 27 because 81 is basically 3 to the 4th, okay? And the cube root of 3. Okay, so I can think of it as 27 times 3. The cube root of y to the 5th I'm going to think of as the cube root of y to the 3rd. And the cube root of, there's 2 y's left over, all over x. So now, cube root of 27 is 3. Cube root of y cubed is just y. These guys are going to group together. 3, or cube root of 3y squared over x. All right. Try them again if you're stuck. It's okay. So try this one. You try it yourself. Let's see what happens. So the first one, I'm going to break up x to the 4th, square root of x to the 4th over square root of y to the 10th. Square root means I'm just dividing that exponent by 2, so x to the 4th divided by 2 gets me x squared. Y to the 10th, 10 divided by 2 gets me y to the 5th. All right, let's do this guy. I'm going to break up the cube root. Cube root of w to the 7th on the top, cube root of 64 on the bottom. The cube root of 64 is 4, so I know that. Cube root of w to the 7th, I'm looking for something that is divisible by 3, so I'm going to make that a 6. Ooh, that's a terrible 6. And the cube root of w. The cube root of w to the 6th is w squared. Cube root of w just is over 4. Okay? All right, let's see what happens here. Now, it is useful sometimes to put things back together. This is an example of that. You'll see why. So I want to make this a regular fraction first. Here's why. P to the 7th over P to the 3rd will simplify, right? That means there's 4 P's left on the top. That means the denominator disappears. This just got a whole heck of a lot easier, didn't it? So P to the, oh, that should be a 4. I was thinking about P to the 3rd on the bottom. So now I have the 4th root of 8P to the 4th. I'm just going to break that up. 4th root of 8, 4th root of P to the 4th. 4th root of P to the 4th becomes just P. So I'm left with P 4th root of 8. If you had just done these each individually, would it still work out? Absolutely. But sometimes it makes sense to approach it, put it back. So we can think about this one the same way, right? We can make it the cube root of 16y to the 4th over y, all under one radical. And then y to the 4th and y just become y to the 3rd on the numerator. So I get the cube root of 16y to the 3rd. Now we got to think about perfect cubes. So 16 I can break up into 8 and 2, cube root of 8, cube root of 2. And y to the cube root of y to the 3rd is just going to end up being y. So let's see, cube root of 8 is 2. Cube root of y to the 3rd is y. And then I have a cube root of 2 left over. Finito. All right, let's try something else. This is another way to think about this. So fill in the missing radicand to rationalize the radical expression. Sounds like gibberish. Basically what we're going to do here is figure out what needs to go here to make it so that I can just get to a, because I want to square root an a squared. So if I have a times radical a what gets me a squared? Well, if I did it like this, if I had another a, that would turn into radical a squared, which is the same as a. So the idea of rationalization is that you're trying to multiply something into the puzzle that will let you simplify away the radical. Here's another idea. Same thing. So I have a cube root of y times the cube root of something gives me the cube root of y cubed. What does that something have to be? Well, cube root of y, I basically need 3 y's and I only have 1. So it's got to be the cube root of y squared. That's going to get me cube root of y cubed. And that's just going to equal y. Try another. This one is a little more steps to it, right? So I have the 4th root of 2z cubed. I want to get 2 to the 4th and z to the 4th under the 4th root. So what am I missing for that to happen? Right now I only have 1, 2. So I need 3 more of them, so 2 cubed. I have 3 z's, so I need 1 more of them to make 4. So this is what multiplies through to get the 4th root of 2 to the 4th, z to the 4th, which just makes 2z. All right. You try these. These you can try on your own. If you're stuck, drop into the chat. Let's see what happens. Okay? Drop into the chat. I keep saying that. Drop into the discussion. All right, let's try this one. Now, here's the issue. The goal in rationalization is that I need to turn what's here into something that doesn't have a radical. This is the thing. We can't have a radical in the denominator of a fraction and have it be simplified. That's just not how it's not one of the rules. So I have to get rid of that radical somehow. I know that if I multiply the cube root of a times the cube root of a squared, I would get cube root of a cubed, and that's just a. So that's where I want to get. The thing I multiplied by was the cube root of a squared. So what I get to do is I can't just multiply the bottom by it. I have to multiply the top and the bottom by it, because what I do to one part of a fraction, I have to do to the other. So what that means is I get 5 times the cube root of a squared on the top. On the bottom, I know cube root of a times cube root of a squared gets me a. So now it's what we call rationalized. There are no radicals in the denominator. Okay? That's the rule. So let's try this one. This one is 2 over the 4th root of y. I can't leave that like that, but I need to make this y just a regular y. So let's think about it. The 4th root of y, I want to turn into the 4th root of y to the 4th. That's what would make that radical cancel. So to get there, I need 3 more, oh gosh, I need the 4th root of 3 more y's. So that's what I'm going to use. So I have 2 on the top. Oh boy, I'm using my eraser a lot today. And then I have the 4th root of y on the bottom. So I'm going to multiply the top and the bottom by the 4th root of y cubed. That's going to give me 2 on the top times the 4th root of y cubed. It's totally okay to have a radical in the numerator. And on the bottom, 4th root of y to the 4th is just y. And it's finished. This gets a little more complicated, right? One step at a time. That's what we do, right? So this one I have to break apart first, because I can't have a fraction under the denominator, or under the radical. So I'm going to break it up into the square root of y to the 5th over the square root of 7. Square root of 7 isn't okay in the denominator. Could you get your calculator and make into a decimal? Sure, but that's not the point here, so don't do that. Okay? I need to get just a regular 7 down there. So I had the square root of 7. Well, I know that if I did the square root of 7 times the square root of 7, I'd get the square root of 49. And that's just 7. So I'm going to multiply the top and the bottom by the square root of 7. It's a square root, so I need 2 7s. That's going to give me, they're both square roots up there, so I can combine them, the square root of 7y to the 5th over just plain old 7. Now you will be tempted to cancel out some things, right? You can't do that with the 7s, but is this simplified? Well, no, because the square root of y to the 5th is not simplified. So now I have to rethink this. So square root of 7, square root of y to the 5th, I'm going to break up into square root of y to the 4th, square root of y over 7. This guy becomes y squared. So y squared, 7 squared, y squared, square root of 7y over 7 is the final answer. You try that one. The answer here, crazy enough, is 2 square roots of 6 over 3. See if you can get it. If not, come into the discussion. Let's talk. All right. The next one is 15 over cube root of 25s. So 15 over the cube root of 25s. Oh, I have to write myself a note while we do this. My brain just thought of something important in your discussion. All right, so what are we going to do? We can't have that cube root of 25s in the denominator. So now I have to think about what 25 is made of in s. 25 is really made of 5 squared, right? And then I have an s. So I have the cube root of that. I want to get it so it's the cube root of 5 cubed s cubed. So I really need one more 5, and I need 2 more s's. So that is what I'm going to do. So I'm going to multiply the numerator and the denominator by the cube root of 5s squared. Cube root of 5s squared. Sorry, my 5s and my s's look the same. On the bottom, that would get me cube root of 5, oh gosh, cubed, s cubed. Too far over, my computer is not liking that. And that's going to be 5s. On the top, I'm just going to get 15 cube roots of 5s squared. That's it. It's done. Okay. You try this one. Rationalize the denominator. Oh, I went the wrong way on pages. Oops. Okay. The answer for this one is going to be 6 cube root of 9y. Oh, that's not right. Cube root of, yes, it is. Cube root of 9y over y. I was thinking square root. Again, hit the discussion if you're not sure. Please, friends. Now, this is when it's trickiest. What I cannot do here, because I have this 6 is being added to something, right? I can't just multiply this whole thing by radical 6. It's not going to work because then I would distribute and I would get a 2 radical 6 there and I'd still be stuck. So that's not going to go. So I'm going to do something different. We learned something in an earlier section that I can make the middle terms of something drop away by using the same binomial with an opposite sign. Okay? This thing right here is called a conjugate. That is what we use to rationalize a denominator when it's got an addition or a subtraction sign. Okay, this is called a conjugate of this. So here's what's going to happen. I'm going to multiply the top and the bottom by this new binomial. And then I'm going to FOIL the bottom. So 2 times 2 is 4. 2 times negative radical 6 is minus 2 radical 6. 2 times radical 6 is plus 2 radical 6. Radical 6 times negative radical 6 is minus 6. On the top, I'm just going to put that up there for a sec. Okay, on the bottom, let's see what happens. These guys cancel. I have 4 minus 6. It's going to be negative 2. No more radical. On the top, I'm going to distribute. So I've got negative 4 minus 2 radical, plus minus times minus, radical 6. So this is pretty done, but these are both even, so I can factor out a negative 2 or a positive 2. It doesn't really matter. I can just factor out negative 2, let's call it. And then I would get 2 minus radical 6 on the inside over negative 2. Those guys cancel. So my answer here is 2 minus radical 6. This is called rationalizing a denominator when, oh, I need another color. When there's something being added or subtracted in the denominator. That's a conjugate. So try it again. What's the conjugate here? It's the opposite sign in the same binomial. 3 minus radical 5. Same thing's going to happen on the top and the bottom. On the bottom, I'm going to FOIL. I get 9 minus 3 square roots of 5 plus 3 square roots of 5 minus radical 5 times radical 5 is 5. On the top, I'm going to distribute. I get 24 minus 8 radical 5. All right. On the bottom, 3 radical 5 and negative 3 radical 5 cancel, so I get 9 minus 5 is 4. And on the top, I have 24 minus 8 radical 5. I can factor out an 8, and that gets me 3 minus radical 5. And I can simplify. Cancel the 4. That's a 2, so 2 times 3 minus radical 5. You can distribute or not. I don't care at that point, so I get 6 minus 2 radical 5. Okay, this is how they all work. Keep at it. This one is a little different. The conjugate looks a little different. Okay? But it's still, it doesn't matter to me what's happening up here in the numerator. It has no bearing on what I'm going to do in the denominator. It is really about the denominator that I'm rationalizing here. So ignore the numerator for now. Think about your conjugate. So it's radical x plus 7. And on the top, it's radical x plus 7. I'm going to FOIL in both spots. So in the denominator, I'm going to get radical x times radical x is x. Radical x times positive 7 is plus radical 7 radical x. And then minus 7 radical x. And then minus 49. Okay? In the top, I'm going to get 4 radical x plus 28 plus x plus 7 radical x. So now I'm going to combine like terms or simplify. On the bottom, I get x plus 49. On the top, oh, sorry, I should get minus. Yep. I get x minus 49. On the top, I can combine those two. They both have the same end. So I get x plus 11 radical x plus 28. There are no squareds. There's no nothing. Everything is connected to each other on the numerator by a plus. And the bottom, there's a minus. There's nothing to simplify here. This is finished as it is. Leave it alone. If there was a common term everybody had to factor out, do that. But if there's not, there's not. You try this one. Works the same as the last one. The answer should be y plus 4 radical y on the top. Oh, sorry, minus 32 on the top over 64 minus y. All right, let's try one more kind. This one, again, just a little more complicated. Same idea. Look at the denominator. What is the conjugate? It is the opposite sign of the same binomial, radical 2 plus 4 radical 5. So that is what I do to the top, radical 2 plus 4 radical 5. And now we just use a little more of our skills. So the denominator, I get radical 2 times radical 2 is 2. Radical 2 times 4 radical 5 is plus 8 radical 5. That's a plus. And then radical 2 times, oh no, it's not radical 8. What's happening here? It was a radical 2. Pardon me. Radical 2 gives me times 4 radical 5 gives me 4 radical 10. Phew. This one gives me negative 4 radical 10. These guys together, think about it. It's going to be negative 4 times 4 is 16. 16 times 5. Okay. 16 times 5 is 80. So 2 minus 78 is going to be the denominator, or 2 minus 80. So that gets me 78. On the numerator, I have 3 radical 2 times radical 2. That means 3 times 2. 3 radical 2 times radical 2 would get me 3 radical 4. Would get me 3 times 2, which is 6. Gets me 6 plus 3 times 4 is 12 radical 10 plus 2 radical 10 plus 8 times radical 5. Radical 5 times radical 5 is 5. 8 times 5 is 40. All right, so then combine like terms on the top. 6 plus 40 is 46. 12 plus 2 is 14. Radical 10. You can simplify this. They can both be reduced by 2. Oh, that's a negative 78. So I could factor a 2 out of the top. That would be 32, oh gosh, 23. Got a little plus 7 radical 10 over negative 78. Negative 78 divided by 2 is 39, negative 39. Oh gosh. And on the top, it's 23 minus 7 radical 10. That's it. That's how it goes. You are going to try the next one. If you get stuck, you're going to hop into the chat or discussion. The final answer to this one, strangely enough, is negative radical 10. Okay? The conjugate, remember here, should be radical 2 plus radical 5. You have the skills to do this. I know you can. Try it. See how it goes. Let's see what happens. Ask for help as you need it. You know how to do that. See you in the next one.